So let's say I want to buy a car. And the car costs, let's say I'm buying a used car, right? We'll keep it small. Let's say I'm buying a used car and it's old and it's cheap and it's $2,000. All right, so I need $2,000 to make this happen. Now, unfortunately, I don't have $2,000. Okay, but there's this guy down the street and he does have the $2,000, right? And he's willing to, not to give it to me, right? He's willing to loan it to me, right? So he gives me his $2,000 and we have an agreement, right? There's a deal in place. 6 months from now, year from now, some time period, I will give him his $2,000 back and I will give him a little something extra. I will give him an extra $50 in exchange for his trouble, right? In exchange for having to do without his $2,000 for the 6 month, 1 year period that I was using that money to do what I wanted, right? This extra bit here that I gave him back, this extra $50, that's what we mean by interest. Okay, so how is this calculated? Let's look at a situation. It's a little more practical, right? We're doing an investment now. So this time you are the loaner, right? You're going to invest $1,000 at 2% for 3 years. And I want to know how much interest will you earn? Well, first, let's be clear about the language. You notice there's no time frame mentioned for that interest. Nowhere in here does it say how often you're going to get paid this 2%. Are you going to just get 2% at the end of the 3 years? Are you going to get 2% at the end of every year, every month, every day? What's the time frame? Okay, this is actually fairly common. Banks are required to give consumers interest rates in what's called the APR. Okay, APR stands for annual percentage rate. So anytime I see an interest amount and there's no time period specified, I can safely assume, at least if you're in the U.S., and I'm sure most Western countries are the same way, I assume that I am being given this as an annual rate. Okay, there's some laws that enforce this, the Truth in Lending Act, some laws that come out of the Great Depression era. It is generally designed to make it easy to compare loans, right? So that you know exactly what it is you're either paying or you're getting. Because if one bank is giving you an annual number and another bank is giving you a monthly number, how do the two compare? Which one is better? Well, it's actually not a difficult calculation, but it's one you might not know. A lot of people probably don't know. So in the interest of getting everybody accurate information, all banks are required to do this. There is one small exception: credit cards. Because credit cards are so monthly focused, right? You make a monthly payment, interest is added monthly. Credit cards are allowed to give a monthly interest rate in addition to the annual percentage rate, right? So they're not absolved of having to do what everybody else is doing, but because of the nature of their business, they are allowed to give an additional version, right? An additional interest number. So what we're assuming here is you're getting $1,000 at 2%, and the 2% is being calculated every year. All right. So let's see how much interest will you earn? Well, at the end of year 1, you will get 2% of $1,000. Right. That is $20. Right. With the end of year 2, you're going to get an additional 2%. You get interest again. 2% of that $1,000 a second time. And then at the end of year 3, you're going to get an additional final 2%, a third $20 payment. If you add up all 3 interest payments, your total interest earned is $60. Okay, well, I mean that worked. You know how math people are. I really don't want to have to do that calculation over and over again, where I'm doing every year and adding them up. Um, it would be especially inconvenient when we start talking about fractions, right? What if you only do this for 6 months, right? Then it's half a year. How do we handle that? So we need a formula, right? We need a formula to be able to handle this. And here's how we're going to do this. All right, I'm going to really kind of repeat the calculation that I just did, but I'm going to do it with variables. All right, so let's say you invest P dollars at R interest. I don't want to put a percent there. We're going to assume that that percentage has already been converted to a decimal. So that'll be the decimal, the version of the interest rate for T years. And we ask the same question. What is your total interest at the end of those T years? Well, I'm going to do what we just did, right? In year one, you get R times P in interest. That's what I did on the previous slide, right? I multiplied the 0.02 interest rate times the $2,000, $1,000, however much the investment was. Now I'm going to do it again. At the end of year two, you get that same amount again. And then this whole process continues for T years. So what am I doing now? I'm adding up RP, well, it's supposed to be a capital P, RP plus RP plus all the way out. And I have T of these that I'm adding up, right? Well, adding up a number T times is the same as multiplying it by T. So this is RP T, and that is the total interest. Now, we don't usually write it this way. There's a customary order to this. This is usually written PRT, principal times rate times time. So there's our simple interest formula, right? It's fairly straightforward, right? You just take the numbers, multiply them together. All right, so in the next lecture in this sequence, we're going to look at some examples. We'll see how we can use that formula to answer a variety of different types of questions.